Hi guys, it's AeroStuff FPV here with a somewhat unusual design from what we are familiar with on the channel. This is a revisioned H-tail pusher design which I built in the past but is redesigned with a fiberglass EPS fuselage which turned out well for the first time using this construction method. This cargo type of fuselage was my choice for this platform to be able to carry at least two 4S2P lithium-ion flight packs in parallel to realize flight times of over 3 hours and 150 kilometers of trip distance on average. With an H-tail pusher like this, the center of gravity of the aircraft is far behind the fuselage and therefore the horizontal stabilizer is designed with a slight rearward sweep which extends the distance of the vertical stabilizers from the aircraft's center of pressure, which benefits directional stability. Its appearance seems small, like a sub 250 gram or 1 meter FPV rig, but it's actually large with a default 1.6 meter wingspan with an all-up weight of exactly 2 kilograms. It has a 600 kV motor with a 13x10 propeller for best launch and cruise performance with my 4S2P lithium-ion packs. Being encouraged to build this design is also by you guys, my supporters that were with me throughout the years, and especially my members. With everyone put together, I'm able to afford and implement new building methods which are more expensive than the standard foam board building methods, but it has excited me to start with something new, knowing that the end result of my future planes will be much cleaner and more rewarding in aesthetics and performance. So from now on, I'll be covering the build process from start to finish with dimensions and additional information given of the fuselage, wings, and electronics. And later in the video, you'll see me fly the plane for the first time and enjoy additional air-to-air flight footage. So sit back, observe, and enjoy the build process of the Atlas Hawk H-tail pusher for long-duration FPV flights. I began by drawing the fuselage form directly onto a sheet of EPS foam which is 1 meter by 50 centimeters with a thickness of 2 centimeters. I chose EPS for its low density, lightweight, and ease of shaping, making it ideal for rapid prototyping. So after I drew the side profiles of the fuselage and the bottom, I started carefully cutting it out using a sharp blade to minimize the foam from tearing and prevent extreme surface irregularities. Once the halves and bottom were cut out, I glued it all together with hot glue. Hot glue might not be ideal, but for the foam builds like this, it's strong enough and lets you keep moving on after just 3 to 5 minutes of drying out. With the fuselage glued together, I moved to the rear taper, which is all about airflow, reducing the form drag and smoothing the transition of the fuselage to the motor. As you guys saw, I taped the two side profiles together, aligned the ends, glued the bottom section to it, and trimmed off the excess. Now the red lines you see here are reference points for smoothing out the fuselage section by sanding and cutting the excess foam to achieve a streamlined bottom structure. I first cut it with a razor blade and used 60 grit and 150 grit sandpaper for this tedious job. After sanding the bottom sides, I started with tapering the nose. This time I used some XPS foam to maintain its alignment and symmetry, and it ended up good enough to start sanding for the last time before glassing the fuselage. To glass the fuselage, I used 200 gram per square meter fiberglass cloth and used a universal clear epoxy resin and hardener with a 2:1 ratio. The rear section was done first, and I started applying the resin carefully and evenly on the sanded EPS foam first. And guys, please be safe with this stuff. Be aware that good ventilation, gloves, and avoiding skin contact are essential when using resins and hardeners to prevent long-term health and breathing issues by the toxic chemicals. After covering the rear section, the fiberglass cloth was placed over the epoxied surface, and then I added another smear of epoxy over the fiberglass. I then let it cure for about 12 hours and then continued with the middle section. And after all the epoxy had cured, I took a razor blade and trimmed away the excess of the edges, and then continued with the nose, which was harder to work with without the cloth healing up, so I did the nose in sections too, which eventually worked out well enough. I also glassed the rear section too, where the motor and tail would be installed. And after all the epoxy cured, I was left with an incredibly strong fuselage and was glad how it turned out without using additional aids like spackle or goop to smooth out the surfaces. Next, I started with the stabilizers, which are made of 5mm thick foam board, and I decided to strengthen the horizontal stabilizer with an additional layer of XPS foam for strength and thickness to support the vertical stabilizers at the outer edges. It's important to precisely mark the center line of the empennage for the stabilizer to be glued. Since I have no rudder, this step is even more essential. Here in my case, I'm gluing the motor mount on first, which is supported with a paint stick to be glued on the top of the fuselage. I glued these joints made of plastic cards to strengthen the tail structure with the fuselage. Unfortunately, this detracts from the aesthetics, but it was my most practical solution in that moment. And that was the tail section finished. Now I could start with designing a detachable 1.6 meter experimental airline style tapered wing made and constructed of a 5mm thick XPS foam. If you guys are not familiar with building this type of wing, click on the top right corner to check it out. Here I sanded the leading edge of the front formers for a sleeker outcome of the airfoil. Having finished the wings, I started with the electronics and started with the servos first. To hold the wings tightly on their place on the fuselage, I drilled the holes for the carbon tie-down rods, and I again went for practicality without the compromise for aesthetics and aerodynamics. In the same manner, the FPV transmitter was installed and the camera hot glued in place, and I was off the flight for the first time. My excuse to bring it out to the field already without properly finishing the fuselage and a reduced aerodynamically clean outcome was to see if this platform would fly to begin with. So this is my spar. Unfortunately, no carbon fiber, just an aluminum spar. And we got the main wings. Just a matter of inserting the spar and aiming for the middle. Haven't marked it. And like that. Plug in the cables and insert the battery, and that's all for it. Fold it over like this. So here I have 6 rubber bands, but I'm gonna do 4. Oh, that's already looking nice. So I already plugged in the battery, an onboard DVR recorder inside as well. Now I just have to put everything inside, cover it with this hatch. Then I'm off to flying this thing. Every time I gotta fly my planes for the first time, something has to work against me. My DVR doesn't work, while yesterday evening it did, and my FPV camera decided to quit on me too, right at this moment. Left, right, up, down, all works. Healthy motor. I think it's a bit on the nose heavy side, but I'd rather have it nose heavy than tail heavy. So that means I have to act quick on the elevator after launching it. Oh my days. Guys, it works. Look at that. What a sight to behold. For how it's flying, without any tuning, is incredible. Hey, it works, and it works well. You guys could see it too. It likes to yaw a bit to the right. And from far out, it actually looks like the HE-162, which is a German World War II jet fighter. When it's up close, it looks like an FPV plane again. Yeah, the fuselage worked out very nice. The Atlas Hawk is a success. I'm so happy it flies. I'm blotting myself there. Hey guys, I'm too excited, man. I think I'm gonna climb up a bit, do a return to home, set up my drone, and get some air-to-air shots of it. The airplane is way too quick. Way too quick. Let's hope this landing goes well. No throttle, drop it in. See it as... Yeah! That's about it. So now I know this FPV airplane flies and has good potential to fly long duration flights with multiple packs inside the fiberglass strengthened fuselage. But before flying it the next time, I'll need to replace the defective FPV camera and see what's wrong with the DVR recorder as well. The battery needs to move about 5 centimeters rearward from its original location to eliminate the big deal of nose heaviness. And with that, I'm thinking about elevating the battery location with a thick EPS block on the bottom of the fuselage because it sits quite low inside the fuselage. This is to try and effectively bring the center of gravity a bit upwards because the center of gravity location also acts vertically if seen from the lateral axis, but especially from the longitudinal axis, and hopefully helps with overall flight performance and increased cruise efficiency. But all of it will be covered in the next video. Thank you guys so much for watching. If you enjoyed the video, give it a thumbs up and make sure to take a scroll through my videos if you're interested in other FPV airplanes of my design and their build videos. Again, thank you guys for watching, and I'll see you guys in the next video.